2020 HSC, so this was just last year's HSC. Which inequality gives the domain of y equals square root 2x minus 3? Well, the aim is, for domain, we want to find out which x values won't work or would only work, either one. In this case, we're going to look at which x values would only work. 2x minus 3 must be greater than or equal to 0. So therefore, just from a simple observation, you can tell that x is greater than or equal to 3 over 2. Is that fine? Question 2. The function f of x equals x cubed is transformed to g of x equals x minus 2 all cubed plus 5 by a horizontal translation of 2 units followed by a vertical translation of 5 units. Which row of the table shows the directions of the translations? If it's a horizontal translation of 2 units, would you have moved to the left or to the right? To the right, and then if you're going to go up 5, then it's actually up 5. Too big. All right, next page. Hey, this one looks familiar. This is what we've been doing with our, what letter of the alphabet? Z. Z scores. So these are going to be our Z scores. Let's have a read. How did I know straight away without even reading it? I see mean, I see score, I see standard deviation. I see mean, I see score, I see standard deviation. Straight away my brain thinks of score minus mean over standard deviation. That's the formula. Has it been memorized yet? Very soon? Yeah. Very soon. Maybe next week when you do another one, and the week after it should be memorized. So 2 more weeks, it's got to be memorized. Let's read now. John recently did a class 10 test in each of 3 subjects. The class scores on each test were normally distributed. The table shows the subjects and John's scores as well as the mean and standard deviation. Okay, I think we get it. Relative to the rest of the class, which row of the table below shows John's strongest subject and his weakest subject? Well, I think we know what we're going to do. 82 take away 70 on 8. 80 take away 65 on 5. 74 take away 50 on 12. Go. Plug it in quickly. What do you get? First one, you'll get 1.5. 1.5? Oh, yeah. Next one, you get 2.8. And the next one you get 2. Obviously, which one's the strongest? Strongest is commerce. Which is the weakest? Weakest is French. Oh. 3. I guess it doesn't change our conclusion. Strongest is still commerce and weakest is French, I said. Why is it? Why do we say higher Z score is stronger? What was the logic? No, too slow. Too slow, too slow, too slow. Think of your normal distribution straight away. And what is it? What's right in the middle? Your mean. And then 1 Z score to the right. Or 1 standard deviation. That's 1 Z score right there. 2 standard deviations. Means 2 Z scores away. 3 standard deviations. Means you're 3 Z scores away. Which means you're all the way up here. So a Z score of 3, meaning you're all the way here, whereas a Z score equal to 1.5, you're somewhere, you're somewhere in here. So that's why, obviously, negative, if it was -3 or -1.5, obviously the -1.5 is better. Yeah. Right? -3 means you're even worse than the -1.5. Make sense? Come on, Eden, what do you reckon? Quick. Okay. Done. Yes or no? It just makes sense. You're more to the right. So that means there's more people here. There's less people here. So obviously you did better because you're in the top end. Okay. Moving? Yes, no? Yes.
French is the strongest.
Sorry?
French is the strongest.
No, it can't be. French is the weakest. Smallest.
So the smallest.
But you can't think like, you got to know why, because I asked you why and you guys couldn't do it. Why? Look, we're here. This is the mean.
Yeah.
1 z-score is here. Yeah. Would you rather be at 1 z-score or 2 z-score? You. Sorry? You. What'd you say? 1. You'd rather be here. But then this was the average. So if the average was 60, would you rather be at 65 or 70? 90, yeah, that's what this is. This is 90, isn't it? All the way to the end. I said you just don't want to be here. You don't want to be at the 10. You'd rather be at 30 than 10. So if it's -3 or -1.5, you got to say -1.5, which is still bigger than -3. So you go for the big. Finished? Okay, good. See, we've done this maybe, I don't know, twice, 3 times. It doesn't matter. As you keep doing exams, you'll get better and better at it. You can do it for 20 weeks. Right? Until you do exams, you will not get better at it. But now, looks like you got that. Let's go. Question 4. Your favorite, what is e plus e to the 3x? A lot of students make mistakes here, but I actually have this in my exponential booklets. It's funny. I put it before this is HSC. What's the answer to e? EX, smart. Like this? Yeah, it is. Plus E, 3x, differentiate the 3, you divide by 3, plus C. The answer is B. Good job. Moving. Yes, number 5. Which of the following could represent this when B is greater than 0? Well, clearly it can't be. Now I'm tossing between C and D. Good point. A lot of students would probably struggle with this because they'll be like, okay, I would have done the y-intercept. That's already given to you. No. That's like this, right? That's like this. What you're thinking of.
Okay.
Don't think like that.
All right.
So out. You got to think about what's the difference between these two. The difference is what's that word called? Vertex. The difference is its vertex. How do I find vertex? There's 1,000 ways by now. Yeah, but why didn't you guys just say y dash equals 0? Just so you know. That's okay. That's why I said there's 1,000 ways. We're going to choose negative b over 2a. Okay. All right, we'll choose that. So x equals negative b onto a. Okay, hold on. Think now. Think. B is positive. So we want a vertex to be negative b over 2a. Which one here would keep me Okay, let's start again, Sam. If b is positive, so think of this as 5. Just think of this as 5 for a second, because I think that's the easiest way. Positive number. When I sub this in, because a is -1, we agree with that? So maybe we'll simplify this to negative b on 2 times -1, which is b over 2. Which one here would show me a value of positive 5 over 2? Positive 5 over 2. C. So the answer is C. Does that make sense? So I subbed in A equals -1, and then I got B over 2. B is always positive, it said, which means I choose that one. If it said B is negative, then obviously I would have chosen D. Are we happy? 100%. We're scrolling down. Number 6. Which interval gives the range of the function y equals 5 plus 2 cos 3? Very easy. When you think of range, you think of its amplitude and the way it's moved up and down. So what is its amplitude right now? 2, which means graphically, my graph is going up 2 and down 2, but then there's a plus 5 attached to it. You said it. So what's the smallest number? What's the highest number? Easy. Good job. Eden, looks like you're showing me like, you okay? Yeah. All right. Don't get rusty with it. I'm 7. Keep it fluent. You've done these before, right? Remember these even during the holidays of this year? We did them. The diagram shows the graph y equals f of x, which is made up of line segments and a semicircle. What is the value of 0 to 12 of f of x? Fair enough. What is the value of 0 to 12 f of x? All right, let's think. I can tell you straight away, let's see if you agree with me, that this area, it doesn't say area, right? So, but this area and this area would actually cancel out. So easier. I'm actually not doing it from 0 to 12. I'm doing it from 0 to 8. That's the first thing I think about. Then I'm like, well, I know from 0 to 4, from 0 to 4, it equals to what? I'm just writing it down for you guys. You said 12 because 4 times 3, which equals an area of 12 here. Good job. Plus from 4 to 8. Okay. Again, what would the bottom area equal to? 12. Plus pi r, what's my radius? 2 squared divided by 2. Why'd you say divide by? Why'd you say 8?
I'm saying the answer is A.
Oh, 8. The answer is A. You are correct. So that's 24 plus 4 divided by 2 is 2 pi. Eden, yes or no? Okay. Would you be doing it at my speed, girls?
No.
That's where you want to be at. You don't need to lie. I'm not trying to put you down like anything. It's not a funny thing. I'm just trying to say you want to see where I'm at, and I guess how I don't think, I just look and I'm there. That's where you want to be. You will be there. You just want to be there before your trials. You don't want to be there at the HSC. Everybody gets there by HSC. That's why it's easy. It's the trials that they're not ready for. So let's try to keep working on it for the trials. Number 8. The graph of y equals f of x is shown. Which of the following inequalities is correct? Okay. Interesting question that this one was, because there was no direction much. So let's see. Let's understand the difference between all of the expressions. What does y double dash mean again to us? Good job, I like that. Concavity. What does y dash mean to us? Increasing, decreasing. Well, I haven't said it equals to anything yet. Increasing slash decreasing, so it's rate. Y dash is its rate.
Was it a year 2 student or year 3?
Year 2. In the second class. And you'll have to take payment as well. Increasing, decreasing. Y is obviously y values, right? And 0 is 0. Okay, so y. Would you say y is greater than 0 or less than 0? So greater than 0. So we already know all of these actually show that 0 is smaller than y. 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 Yes? Which means we can't use that one, unfortunately. Next logic. Rub. All right, next logic is is this, let's look at concavity for a second. Oh, actually, let's look at increasing, decreasing. Is this increasing or decreasing? It's increasing, so we know y dash is greater than 0. In other words, we know 0 is less than y dash. 0 is less than y dash, 0 is less than y dash, 0, damn it. All of them show that 0 is less than y dash. Also can't use that. Hey, remember, it's getting to question 8 now. Y double dash, concavity. Is this concave up or concave down? Well, it is concave down. What does that mean? Y double dash, if it's a maximum, less than 0. If y double dash is less than 0, finally, we can knock off C, we can knock off D. Now we're looking at these A and B and tossing up, is the gradient smaller than the y value, or is the y value smaller than the gradient at that point? Tricky. Is the gradient smaller than the y value, or is the y value smaller than, okay, tricky. I'm not gonna lie to you. The only students that would have been able to get this right are those who actually understand the idea of calculus. So if you've just done calculus, it's not enough. You actually need to know the theory of it as well. And that's what happens when you get to the high end of questions. So here we go. Gradient. Well, pick a y value for this. Pick a y value. 2. That's what I mean by theory. So you first would have done that. So there's its y value. Now let's find its gradient. How do I find gradient? Well, of course, y dash, but you don't have y dash, so what are you going to create? A tangent, so that you can create its slope. You can find its slope. What is the rise here from 2 to this number? Just pick it. 1. Good. What's your run here? 1. What's your gradient? 1. So is f dash of 1, which equals to 1, bigger than or smaller than f of 1, which equals to 2? Well, f dash of 1 is actually smaller than f of 1, so the answer must be A. The gradient is smaller than the y value. Don't let one question make you feel like that. Remember, if you get 99, we're all happy still. So don't think like this. And plus, even if you get one wrong, you're still 100% right because you get scaled up. So just relax. Stop thinking like that. Just learn. Learn. Don't worry. Number 9. Number 9, our favorite. Suppose the weight of melons is normally distributed with a mean of U and a standard deviation of sigma. A melon has a weight below the lower A melon has a weight below the lower quartile of the distribution, but not in the bottom 10% of the distribution. But not in the bottom 10%. Which of the following most accurately represents the region in which of this melon lies? Okay, the weight of this melon lies. All right, let's remember our numbers first before we start this. So this was 34%. Then what was the second one? So that was one standard deviation away. What was the next one? The next one was 13.5%. Then the next one was, if it was like up to the third one, I think 2.35. So it went 34, 13.5, 2.35, and the last one is 0.15. So like this. This is 34%, the next one's 13.5, the next one is 2.35, and then whatever's left is 0.15 on both sides. And it's obviously symmetrical, so 34 here, 13.5 here, 2.35 here, and 0.15 there. Yep. All right, it says a melon has a weight below the lower quartile of the distribution. So below the 25% mark. So if it's below the 25, this is 50%. right there. 25% would be, yeah, 25% would be somewhere over here. So below the 25% mark, which is all of them, except this guy. So definitely not C. Oh, and it's not B. And it's not B. All right? It's between A and D. Do we get that? It's below this part here. And so it can't be B or C. And then of course it says, but not in the bottom 10%. That looks like it's going to the bottom 10% now. So there, obviously it's not A. The answer is D. Move on. Number 10. Nope.
So lower quartile was 25%.
Because quartile, lowest quartile is 25%, right?
Yeah.
Upper quartile is 75%. So if you're in the higher 75% of your results, you'll be somewhere over here, 75%, for example. Because this whole thing's 100%, right? If you add up all these numbers I've written, it's all going to be 100%. So you got to work out, if you want it to be 25%, take away 0.15, take away 2.35, take away 13.5, but you're somewhere around here. 25% somewhere around there. Make sense? Number 10. The graph shows two functions, y equals f of x and y equals g of x. Define h of x equals f of g of x. How many stationary points does y equals h of x have? Again, it's not one that every student in the state would have gone right. It's probably one, I would say, less than 1%. Less than 1% would have got right. I'll show you how it's meant to be done. Because it's not an easy one. Well, it is actually quite easy. It's just that if you haven't done one before, you would not know exactly what to do. Great. Great. That's what I mean. So if you've been exposed, that's excellent. Let's have a look. Define h of x as f of g of x. How many stationary points does y equals h of x have? Okay, you got to understand, if it's stationary points, what do we need to do? We need to make h of x, we need to do h of dash of x equal to 0. Correct? What is h dash of x? Well, h dash of x would be the derivative of this function times by the derivative of the inside. The derivative of the function times by the derivative of the inside. Still good? Where, and then that equals to 0, obviously. Where does g dash of x equal to 0? G of x is this one here, right? This gray one. Where does that equal to 0? G dash of x equals to 0 at x equals to 3. Good job. So we found one stationary point. How many stationary points will it have? We at least know it's going to have one. So it's definitely not A. Now we're looking at the next component, which says f dash of g of x must equal to 0. F dash of g of x must equal to 0. F dash of g of x must equal to 0. For that to occur, we need to work out when would the derivative of this No. Let me recall what I've done. F dash of g of x equals 0, and g of x equals 2, and g of x equals 2. One and a half and 4.5. g of x must equal to in f dash of g of x must equal to 0. So where would f dash of g of x, so that's g of x must be at, yeah, f dash of 1, okay, that's what I was looking for. All right, can you see that at 1, there's a stationary point there for f dash? Can you see that at around, I don't know, around, let's just do at 1 for now, make it easy. So f dash of 1, let's not worry about the second one. F dash of 1 equals to 0 is a stationary point. We agree with that. What can you conclude from that? You can conclude that g of x must equal to 1. How many times would g of x equal to 1? No. 1 and 2. So how many times would you be able to solve this one? Technically, twice. You're going to get two different solutions. What would the solutions have been? X equals 1.5, x equals 4.5. So altogether, how many stationary points would you be able to find? 3.
Wait, where did you get the 1.5?
Well, technically occurs at. That's what I'm trying to say. Roughly. I mean, I'm just taking a guess, but
Yeah.
stop the recording.